Okay, question number 15. And real quick, this question was also on the AP Calculus BC practice exam. So they did reuse this one. So if you can solve this question, that's really good. So we have the graph of differentiable function f is shown above. If h of x equals this function, which of the following is true? So a couple things. If we look at our answer choices, we know that we're going to need h of 6, h prime of 6, and then h double prime of 6. So the first thing that I'm going to do is I want to figure out, okay, what is h of 6? If I have h of 6, then I'm going to go ahead and plug in 6, where I see that x right there, for f of t dt. Now, I don't know what f of t is. Like, they don't give me the actual function, but I do have this graph here. And if I know what an integral is conceptually, then I can solve it. So remember, the area, or I should say, the integral is the area of the curve, right? So what I'm going to do is look here and recognize that from 0 to 6, all of my y values are negative. So therefore, I have all this area right here. And sorry, therefore, the area is negative. So what that means is that h prime of 6, even though I don't know what it is, I at least know that it is negative. And hopefully you can see how that's a negative area. All right. So let me clear that off real quick, and let's go ahead and figure out what is h prime of 6. So if I take the derivative of h of 6, sorry, h of x, then that is the same thing as taking the derivative of this integral here. And if I do that, then by the fundamental theorem of calculus, I have that this is just going to be f of x. Or wait, did I do that correctly? F of x, yes. Okay, f of x. Now, if I evaluate this when x equals 6, then I have that h prime of x is equal to f of 6, which is equal to, and then you have to go figure out, if y equals 6, or sorry, excuse me, if x equals 6, what is y? So let's go ahead and look at that. So when x is 6, I see that my y value is actually 0. So if it's 0, then that's just the answer. All right, now for the last one here, I want to figure out what is h double prime of x evaluated at 6. So I know that, h double prime of x, well, that's just equal to the derivative of h prime of x. And if h prime of x is equal to f of x, then this is just the same thing as saying the derivative of f of x. And I know that that is going to be f prime of x. So therefore, if I have h double prime of x evaluated at 6, then I really have f prime of 6. So I cannot give necessarily an exact value. I mean, I can make an approximation. But if I look at this, I know that the derivative is the slope, right? So I want the slope, I want the slope when x equals 6. So what I'm going to do is I'm going to go back here to 6, and I'm going to approximate what that slope is going to look like. So it should look something like this, right? That's going to be the tangent line. And as you can see, it is positive. So now I have some way to compare the two, right? So the negative value has to be the lowest. So I want, it's going to be h of 6, right? And I know that that has to be less than 0. So that's going to be less than h prime of 6. And then I know that 0 is going to be less than any positive value. So therefore, h double prime of 6 has to be the greatest. And that is going to be answer choice A. All these other ones get it mixed up. So yeah, hopefully that makes sense. I like this problem. It's a good conceptual one. I think this is something you can potentially learn a lot from. So yeah, if you have any questions, feel free to comment below, and I'll see you guys in the next video.